All right, welcome back, geometry. And today we're going to talk about perpendicular lines. Remember, yesterday we talked about equations of lines, specifically those that were parallel. So, real quick review: if they're parallel, we know they have the same slope. They're going to run parallel to each other. They have the same slope. If they're perpendicular, that is not the case. So, perpendicular would be something like this, because perpendicular lines form right angles. So here they cross, forming four right angles. And you'll notice if one is up to the right, positive, the other one is down to the left, negative. So their slopes are going to be opposite. And not only if this is up 1 over 2, then this one would be down 2 over 1, opposite. And when they switch like that, reciprocal. So in order to find the perpendicular slope, it's the opposite reciprocal. So if we look here at this first one, 2 technically is over 1. This is positive, so the opposite becomes negative. Let me make this a little bigger so it's easier to see. So negative, and then the reciprocal, they switch, so 2 over 1 becomes 1 over 2. This next one was positive 9. It's going to be negative, and then it's going to become 1 over 9. Next one, negative 1/2 becomes positive 2, or you can put 2 over 1. Next, we got negative 4. That'll become positive 1/4. Negative 2/3 becomes positive 3 over 2. 3/5 goes to negative 5 over 3. I'm going to skip this one because it's probably the most difficult. We'll come back to it. But negative 2 becomes positive 1/2. Negative 4/5 becomes positive 5 over 4. 7 goes to negative 1/7. Negative 3 becomes positive 1/3. And 4 would be negative 1/4. Then the final one here, 1. Technically, 1 is just 1 over 1, so it's going to switch to negative. The opposite reciprocal still stays as 1. As if you switch the 1 and the 1, it's still just 1. So that is how we find the slope of a perpendicular line. Now, if we look here, just like we did yesterday, we're going to use our point slope form and then eventually get it into slope intercept form. However, the difference is it says we have an equation here that passes through the point 2, 0 and is perpendicular to the line y equals 2x minus 1. Yesterday, all our equations we were dealing with were parallel. So it's perpendicular, meaning if the original slope, which we can find is 2, our perpendicular slope is the opposite reciprocal. So that'd be negative 1 over 2. So let's set that up. Y minus 0, I'm getting this from right here, equals negative 1/2 parenthesis x minus 2. Y minus 0 just becomes y. We distribute negative 1/2 x. Negative times the negative is positive. Half of 2 is just 1. If you aren't sure how I did that, negative 1/2 times negative 2 over 1 would give us 2 over 2, which reduces to 1. All right, example 2 here, very similar. Once again, going through the same point 2, 0. Still perpendicular, however, the slope has changed. The original slope is now 1/2. So our slope of a perpendicular line would be the opposite reciprocal. It was positive, so it goes to negative. Instead of 1/2, it's going to be 2 over 1. So negative 2 is our slope. And now we can once again set it up. Y minus 0 equals negative 2 parentheses x minus 2. That'll just be y equals, distribute this in, negative 2x plus 4. And we are done. Okay, we got one more example like this to do together. This original slope is negative 2. So since it's perpendicular, remember if it was parallel, that'd be the slope we'd use, but it's perpendicular. So it's going to be the opposite reciprocal. Instead of negative, it becomes positive. Instead of 2, it becomes 1/2. So our slope we're going to deal with is 1/2. And now we're going to plug in these points. So it'll be y minus 3 equals 1/2 parenthesis x minus, oh shoot, I flipped my x and my y. So let me fix that. Okay, so Oh no, I did that right. Y minus 3 equals half times x minus negative 4. So we do plus, plus, and from here we can distribute that in, and we're going to get y minus 3 equals 1/2 x plus 2, because half of 4 is 2. Add the 3 over, and we'll get y equals half x plus 5. All right, so now take a look, and here we have a situation with our line, and our job is we want to draw both a parallel line and a perpendicular line. So let's start with the parallel. That's easy, hopefully. So let's find our slope. The original slope, just put 2 points on there, goes up 1/2. So the slope is 1/2. So a parallel line, you can choose any point along here. Just choose a starting point. Go up 1/2, up 1/2, or down 1, left 2, down 1, left 2. And that line, as you can see, is parallel. Now, if we switch it up and we find our perpendicular, instead of 1/2, it would be the opposite reciprocal, so negative 2. So once again, choose any point on here. Then the slope is down 2/1, down 2/1, down 2/1, or up 2, left 1. And if I draw through the, oops. As you can see, we have our 4 right angles here formed, and 4 right angles formed because it is perpendicular with both of those. My line is not perfectly straight, which I think is why the angles maybe look a little off. But let's do one more of these. So if we look at this one, the original here, and we can go, we know the slope, it goes down 4, 1, 2, 3, 4 over 2. So negative 4/2, which reduces to just negative 2, which means if it's parallel, it's going to have that same slope. So once again, choose any point. If I choose right here, go down 2/1, down 2/1, or up to left 1, up to left 1. And that line is parallel. Once again, I'm not a perfect drawing lines, so it's not perfect, but it's pretty close. Now, the perpendicular one would be the opposite reciprocal. So instead of negative, it's going to be positive. Instead of 2, it's going to become 1/2. So choose any point, and oops, if I go up 1/2, or I could go down 1/2, down 1/2, and that line would be perpendicular to both of those. So once again, take a look at today's Delta Math. There's a new one for today. Make sure you're getting your work done, and if you have any questions, please let me know tomorrow or send me an email. Have a great day.